The overriding purpose of MapReduce is to process large data sets in parallel. For instance, you might have web servers across the country and you want to do an analysis of all their web traffic from their logs. Data is normally contained on distributed computers, and this takes advantage of locality while processing distant data sets. So here are the steps for MapReduce. First, individual workers process map data. This is similar to Haskell and Lisp, which are able to map functions to entire data sets. So in the map process, a function is applied to a data set. This result is then written to a temporary storage file. The second step is the shuffling step. This is where data is shuffled so that all data belonging to a given key is staged for a single worker node. Finally, the data is reduced by the worker nodes working in parallel. So I have written a demo program to show you these steps. There are 3 sets of data that will be mapped. These each represent files on 3 different drive arrays. Each data set will be mapped by adding together the file sizes for the files. The files will then be mapped to a key representing the first character of the file name. This means that there will be 26 keys, A and B, to name 2. Finally, the 26 data files will be reduced to a single result file, which can then be analyzed. Okay, so let's take a look at this program. First, as you can see, I have 3 file names. These represent the data sets. Then I have the destination for the counts. Since we have 3 data sets, it will record all 3. And there are 26 mapped keys. So we start off with this map function. We clear out our total buffer. We open the file. We keep going until we're out of file. And now we do an fscanf for the file name and the file size. And here we're going to get the first character of the file name. That's going to be our key. And just for this demo, we're only going to do A through Z, so we'll skip anything else. We've got to subtract here so we have a 0-based index. And we just update the file size total. Now, just so we have a reference here, we're going to have a temporary printout of those results. And one thing I failed to mention is we're going to do these maps in parallel using an OMP parallel for. So let's go ahead and run this program now. And it just takes a few seconds to run and finish. And then we'll see the results. And there you are. These are fairly big numbers. That's why I used a long int. Okay, now for the shuffle phase. Suppose that we're collecting data on these remote servers. Now what we're going to do is save the mapped data to shuffled files on the local computer. In this way, then we can locally load in those files and analyze them. So here I have a for loop which walks through 0 to 25 representing A through Z, and it creates a file and saves the data. So what I'm going to get are 26 files, which is a result of the mapping of the original 3 data files. Finally, we do the reduce step. And I have a simple for loop, which is inside of an OMP pragma for, which calls a reduce function. And let's go on up here to the reduce function, create the file name, open the file, read in the 3 data values, and then update the total file size. Now back here at the end, I just print out the total file size, and we have the reduction. Now you might be asking, well, why don't I just do it all in one single step? So this demo actually is illustrating what would happen on, for instance, all of these steps would happen on remote machines. I'm simply using my local machine right now to demonstrate it, but theoretically these would not happen on the same machine. The shuffling would also not happen on a single machine. It would shuffle to your key identified data files or data sets, and then those would be transported back to the local machine, which would then do the reduction. Finally, a single machine would do the reduction. But the point here is that we're able to deal with large data sets in this manner so that with map, shuffle, and reduce, we can do this. So in conclusion, the MapReduce paradigm, which was originally developed by Google, is in wide use as a generic paradigm to deal with large data sets. This simple demo that I've shown you gives you the fundamental building blocks of the process.